Alright, Chapter 3, Welding. In the Navy, as well with the private industry, welding is widely used with the metal workers, fabrication, maintenance, with the repair of the parts and structure of all of the other methods with the joining of the metals. Welders are one of the most convenient of the rapid methods available. The term welding refers to the process of joining metals by the heating of their melting temperature, for the causing the molten metals to flow together. These ranges run from simple steel brackets to nuclear reactors. Welding, like any skill trade with a broad scope, is whether you can become a welder simply by reading a book. You need practice experience as well with the patients, however, much can be gained through study of the instance of the learning of the correct method of the procedure for accomplishing the job of the book. From a book, you can eliminate many mistakes otherwise would occur through the trial and error. This chapter is designed to equip you with a background of the basic information applicable to welding in general, with the take the time to study the material carefully to provide you with the foundation needed to become a skilled welder. Welding process. Welding is not new. The earliest known form of the welding, called forge welding, dates back to the year 2000 BC. Forge welding is primarily a process of the joining metals, heating of the hammering until the metals are fused and mixed together, although forging welding still exists and may be limited with blacksmith trades. Today, there are many welding processes available. The Figure 3.1 provides a list of processes for the modern metal fabrication and repair. This is published in American Welding Society. Shows the official abbreviation each of the process for the RSM. The resistant spot welding and shield milk arc welding is an arc process that fuses the metal by heating them with an electric arc created between the covered metal electrode and the metals being joined. Often welding process listed in Figure 3.1. Shield metal arc welding, called stick welding, is the most common welding process. The primary difference between various welding processes are the methods which heat are generated to melt the metal. With the one that you understand the theory of the welding can apply to most welding processes. Most common type of welding are often oxy-fuel, gas welding, arc welding, resistant welding. As a steelworker, your primary concern with the gas arc welding. Primary difference between these two processes and methods used to generate heat. Gas welding. Once on most of the popular welding methods use the gas flame source for the heat, the oxy-flame fuel gas welding process. Heat produces burning combustible gas such as a meth or methyl acetylene propylene acetylene mixed with acetylene mixed with oxygen. Gas welding is widely used for the maintenance repair work because of the easily transportable oxygen fuel cylinders. Once you learn the basic gas welding, you will find the oxy-fuel process adaptable to brazing, cutting, and heating, treating all types of metals. Learn more about that gas welding in Chapter 5. Arc welding. Arc welding is a process of the electric arc to join the metals being welded. The distinctive of the arc welding or over the gas welding concentration or heat. Gas welding, a flame spreads over a large area. Sometimes using heat, distortion, concentration, heat characteristics. Arc welding advantage because with less heat, but the spread be reduced the buckling and warping. Heat concentration also increases the depth of the penetration speeds of the welding operation. Therefore, you can find that arc welding is often more practical and economical than gas welding. All arc welding processes have three things in common: a heat source, filler, metal, and a shielding. Source of the heat or arc welding is produced by the arc of the electric current between two contacts. The power source is called the welding machine. Simple welders should not be defined in the same term as also the to describe a person performing the welding operation. Welding machine is either electric motor powered naval construction forces. There are too many types of the arc welding process with which you should become familiar with. Too many types of the arc welding. You should become familiar with the arc shielding, arc weld, and the gas shield arc arc weld. Alright, show the table of arc welding, AW welding processes, and solid state welding, resistant welding, brazing, other welding, oxy-fuel, gas welding, adhesive welding, arc cutting, soldering processes, allied, thermal spraying, adhesive bond, cutting, thermal, oxy cutting, arc cutting, and other arc cutting. Alright, shows a guy doing a flat in a T-joint. Shows the welding torch ship, inner cone, acetylene feather, molten weld, the tip, filler rod, solidified metal. Then it shows on the left, that's oxy-fuel, gasoline, Figure 3.3, shield metal, arc welding, electrode wire, electrode coating, arc, metal droplets, protective gas, molten weld, slag, and solidified welded metal. Alright, shielded milk arc welding is in Figure 3.3 is performed when striking arc between coated metal, electrode-based metal. Once the arcs have been established, the molten metal with the tip of the electrode float together the molten metal with the edge of the base metal with the form of silence joint. Process known as fusion. Coating from the electrode forms a covering over the weld that deposits shielding it from contamination through the process called shield metal arc welding. Main advantage of shield metal arc welding is high quality welds are more rapidly at a low cost. You will learn more about the shield metal arc welding in Chapter 7. Gas shield arc welding. Primary difference between shield metal arc welding and gas shield arc welding is the tip of the shield with the gas shield with the welding both the arc and a molten puddle with covered with a shield inert gas. Shield inert gas prevents atmospheric contamination through by producing a better weld. But the primary gases used for the process are helium, argon, and carbon dioxide. In some instances, the mixture of these gases used for the process used the gas shield arc welding known as gas tungsten arc welding or MIG. You'll also hear these called TIG and MIG, gas shielding, arc weld melting, extremely useful because it uses weld all types of furious, non-furious metals, all thickness. Now, we've discussed a few welding processes available to which one should choose. And there are no hard or fast rules in general. The controlling factor for the type of the metal, with the joining costs involved with the nature of the product, of the fabricating, the techniques used to fabricate them, because of the flexibility, mobility, gas welding is widely used maintenance, repair work in the field. Only on the other hand, you should probably choose a gas shield metal arc welder to repair critical pieces of equipment made with aluminum and stainless steel. No matter welding process, you should there in some basic information you need to know. The remainder of the chapter devoted to the type of the information. Study the information carefully because all you allows you to follow the welding instruction. Read welding simple various types of joints using proper welding techniques. Welding terminology becomes school, although you first need to learn the technical vocabulary of the welding. Section chapter introduced with some of the basic term of the welding language. Once you understand the language of the welding, you will be prepared to interpret and communicate welding information accurately. Alright, then it shows the gas torque, tungsten, or arc welding. You have the direction. You have the shielded gas, molten metal pole, solidified welded metal, base metal, direction travel, welding torch, arc, tungsten electrode, filler. In the gas metal arc welding, you have a shielded gas, molten welded pool, solidified welded pool, melting base metal, direction of travel, and that's the electrode arc. Alright, filler metals. When welding two pieces of metal together, you often have to leave the space between the joint material that you add to fill the space during the welding. The process known as filler metal, or material. Two types of the filler metal commonly used for the welding are welding rods and welding electrode. The term over the welding rod form refers to a form of filler metal that does not conduct electrical current during welding process. The only purpose of the welding rod is to supply filler metal to the joint. The type of the filler metal is often used for the gas welding. Electric arc welding, the term electrode refers to the component of the conductor of the current with electrode holders for the metal being welded. Electrodes are classified by two groups of the consumable and non-consumable. Consumable electrodes are not available, or not only provided for a current, but they also supply a fuller metal to the joint. An example of the electrode has been shield metal arc welding. Non-consumable electrodes are only used as a conductor for an electrical current, such as in gas tungsten arc welding. Filler metals of the gas tungsten arc welding are hand-fed consumable weld rod. Additional information about filler rods electrodes can be covered in chapter 12 that deal with specific welding processes. Alright, fluxes. Before performing any welding process, you must ensure the base metal is clean. No matter how much of the base metal is physically clean, it still contains impurity. The impurity is called oxides, result of the oxygen containing combining in the metal with the other contaminants in the base metal. Unless the oxides are removed, the use of the proper flux. A faulty weld may result in the terminal flux. Refer to the material used with the dissolved oxides. Release trapped gases, slag, impurities from the base metal. Those fluxes can be thought of as a cleaning agent performing the function of the flux. Allows the filler metal and base metal to be fused. Different types of fluxes are used with different types of metals. Therefore, you should use a flux formula with a specified base metal. Beyond that, you can select the flux base with the expected solid brazing or welding temperature. For example, when brazing, you should select a flux that becomes liquid at a correct brazing temperature when the metal was at known times. Add filler with the ideal flux with rapidly fluidity at the welding temperature and thusly blankets the molten metal with the oxidation. Flux are available in many different forms. There are fluxes for the oxide fuel, gas applications, predominantly bracing and soldering. Fluxes usually come in the form of the paste or powder or liquid. Powders can be sprinkled on the base metal. The fuller rod can be heated and dipped into the powder. Liquid paste and fluxes can be applied with the filler rod and base metal with a brush. For shielded metal, arc one of the fluxes on the electrode. In this case, the flux combined with the impurities in the base metal, floating them away from the form of heaving heavy slags when shields or welds from the atmosphere. You should realize that no single flux satisfactory universal. However, there are a lot of good and general purpose fluxes with the common metals in general. Good fluxes are following characteristics. It's fluid and active at the melting point of the fuller metal. Remains stable. It does not change vapor rapidly with the temperature ranges. Welding procedure to dissolve all oxides removed from the joint surfaces. Adhere to the metal surfaces that are being heated. It does not ball up and blown away. It does not cause a glare that makes it difficult to set with the progress of the welding braids. It's easy to remove it after the joint is welded. It's available. It's easy as applied to form. Caution, nearly all fluxes give off fumes that may be toxic, usually on the well-ventilated spaces. It also is good to remember all welding operation require adequate ventilation whether flux is used or not. Alright, the welding joint and two or more metal points are joined together. There are 5 basic types of welding joint: butt, corner, T, lap, and edge is shown. You have the butt weld, corner joint, a T joint, a lap joint, and then you have the edge joint. Alright, over here we show the root joint openings of butt, lap, T joint, double bevel, single bevel, open groove, double bevel, root face, groove face, root face, groove face, groove face, root edge, groove face. That one's a single bevel. And it shows the groove in the root face, and then a butt to weather, root groove, and root face. Alright, you see the groove angle, bevel angle, root opening, groove angle, bevel angle, root opening, bevel angle, groove angle. Alright, a butt joint is usually the two members aligned in the same plane with the joint. Is frequently used in plate, sheet metal, and pipe work. As at a joint, this type of may either be square or grooved. Some of the variation joints are discussed later in this chapter. Corner and T are used. Join two members located with the right angles to each other. The views B and then C with the cross-section joint. Corner joint forms an L shape with the T joint shape with the letter T. Various types of the joints designed with the both types used with many of the type of metal structures. A lap joint with a name and ply with it made with the lapping one piece and now over another. This one strong with the type of the joints available to have the maximum joint efficiency should overlap the metals of the minimum of 3 times the thickness of this member you are joining. Lap joints are commonly used for the torch brazing and spot welding applications. Alright, edge joint, you with the toe joint, the 2 or more members lying in the same plane. In most cases, one of the members is flange, as shown in figure 3.6 of view E. While this type of joint has some application plate work, most frequently used in sheet metal work, an edge joint should only be used for joining metals 1/4 inch or less, and thickness that may not be subject to the heavy loads. The above paragraph discusses only the basic 5 type of joints. There are many possible variations. Later in this chapter, we will discuss some of the variations. Part joints, parts of the joint. Whether there are many joints for the parts of the joint described by the same term of the root of the joint, of the portion of the joint where the metals are closest to each other. Shown in figure 3.7 of the root opening. Root may be a point, a line, or an area viewed in the cross-section groove. It is an opening or space provided between the edge of the metal to the weld. Groove face, the surface of the metal part included with the end in the groove. In view A, figure 3.8. A griven joint may have the root face or a root edge. Root face is shown in view A. Portion A, prepared edge part to be joined with a groove weld, has not been grooved. As you can see, the root face relatively small dimension. Root edge, basically a root face of 0 width, is shown in view B. As you can see with the views called from C and D, illustration, groove face, root face, same metal surfaces, some joints. Specific requirements, particularly with the joint expressed on the surface, term, bevel angle, groove angle, radius, groove root opening, brief description on each term of the shown figure 39. Bevel angle is the angle formed between the prepared edge of the member and a plane perpendicular surface of the member. The groove angle is the total angle of the groove between the parts of the bead joint. For example, the edge of each of the two plates were beveled at 30 degrees. The groove angle would be 60. This is often referred to as an included angle between the parts of the joint and groove weld. All right, we'll look at the root penetration, joint penetration methods. All right, A, show the root penetration, joint penetration. B, show the root penetration, joint penetration. Root penetration, joint penetration, and D, joint penetration, E, joint penetration, root penetration, joint penetration. 311 weld reinforcement, face of the weld. Face reinforcement is from the face of the weld to the root reinforcement. Figure 312 is a simple weld bead. Alright, groove radius is used to form in the shape of the J or U groove weld the joint, usually only for the special groove joint design. Root opening for separation between the parts joined with a root opening and sometimes called the root gap. The determinant of the groove angle of the groove angle root opening joint must consider the thickness of the weld. The material type of the joint made for the welding process to be U for the general, U for the gas welding requires a large groove at the angle of the manual arc, metal arc welding. The root opening is usually governed by the diameter of the filler metal, but this turn depends on the thickness of the base metal of the welding position. Having adequate rooting opening essential for the root penetration. Root penetration, joint penetration, weld shown in Figure 310. Root penetration refers to the depth of the weld extends into the root of the joint, and the root penetration measured from the center line of the root over the cross section. Joint penetration refers to the minimum depth of the groove the weld extends from the face and into the joint, exclusive of the weld enforcement. You see the figures from the root penetration, joint penetration, often refer to the same dimension. In this case, views A, C, and E of the illustration. View B, however, show the difference between root penetration and joint penetration. View D shows the pepper penetration only. So here's the penetration, root penetration. Weld reinforcement is a term used to describe weld metal except for the metal necessary to fill the joint. Alright, so we have a square groove weld, a square groove weld, single bevel groove, double bevel groove weld, single V groove weld, a double groove weld. Alright, types of the metal. There are many types of welds. Some of the common types you will work with: a bead and groove fillet, surface tacking, plug slot, and resistance. Being the first step of the weld with the learn with the produce of the weld bead referred simply to the welded bead. A weld bead is welded deposit produced with a single pass of one over the welding process. Example of the welded bead is shown in Figure 312. Weld may be either with a narrow or wide, depending on the amount with a transverse oscillation side to side move with the U of the welder. With a great deal of the oscillation, the bead is wider. When there is little or no oscillation, the bead is narrow. The weld bead made without which weave motion is often referred to as a stringer bead. On the other hand, weld bead made with side-to-side oscillation called the weave bead. Groove welds are similar welds. Simple welds give the groove between two members to join. The weld is adaptable variety of butt joints from Figure 313. Groove welds may be joined one or more welds and bends depending on the thickness of the metal. The two or more beads deposited in the groove of the weld is made with a multiple pass layers shown in Figure 314. As a rule, multiple pass layers made with a stringer bead with a manual operation. Steelworker use groove welds frequently in the work, and another term you should be familiar with is when making multiple pass weld is build-up sequencing shown in Figure 315. Build-up sequencing refers to an order which bead welds multi-pass weld are deposited in a joint. Note, often the instructions specify that the inter pass temperature. The inner pass temperature refers to the temperature below the previous deposited welded metal, but must be before the next pass be started. Alright, so here we have Figure 314, multiple pass layers. Then it shows the weld layer sequence for the double bevel groove. Shows 1, 2, 3, 4, 5, 6. Shows a lap fillet, a T-fillet, and a corner fillet, a surfacing weld, plug weld, and a slot weld in Figure 318. Half of the effect of the heating of the metal discussed later in the chapter. You understand the significant building up of the sequence, importance of the controlling the inner pass temperature across the sectional view fillet weld is with the triangular shape of the weld is usually to join two surfaces with the approximately right angles to each other, lap T and corner joint, figure 316. Servicing. The welding process applied with a harder, wear-resistant layer of the metal surface at the edge of the worn-out parts, one over the most economical method conserving the extending life of the machines and tools construction equipment. As you can see in figure 317, surface the welds composed of one or more of the stringer or weave beads. Sometimes surface known as hard-facing, wearing surfacing, often used to build up the worn shaft of gear or cutting edges. We'll learn more about the type of the welding in Chapter 6 of the training manual. Tack weld is well made with the holes part of the assembly proper to alignment temporarily on the final weld of the made, although the shape of the tack welds are not specified normally between 1/2 inch, 3/4 of an inch in length, never more than 1 inch in length, and determining the size of the number of the tack welds for the specific job, you should consider the thickness of the metals to be joined and complexity of the object being assembled. Plug and slot welds are the welds made with the through holes and slots in one member of the lap joints of the welds are even to join with the members of the surface of another member of the hex being sewed throughout the hole may or not be completely filled with metal. These types of welds are often used to join hard face hardening plates with the back or soft side, install liner plant metals inside tank, or fill up holes in plate. Resistant welding is a metal fabrication process of which the fusing temperature is generated with the joint with a resistant flow of the electrical current accomplished by the clamping of two or more sheet metals between copper electrodes passing through the electronic current through them, where the metals are the heated with the melting temperature forging pressure is applied through either manual or automatic means of the welding pieces together. Spot and seam welding are two common types of resistant welding process. Spot welding is probably the most common use of the type of the resistant welding. The material is joined with a place where the two electrode pressure is applied. The extra charge of electricity is sent through one electrode through the material to the other electrode. Spot welding is especially used in fabricating sheet metal parts. Seam welding is like spot welding, except that the spots overlap each other, making continuous weld. Alright, figure 319 shows spot and seam welds. You have the nuggets, your spot weld, seam weld. Alright, here we have the elements of the size of the weld, original surface work, the toes, the reinforcement, the face, the fusion zone of the filler and penetration, your root opening, and your roots. And, alright, now we show the 320, the fillet parts of the groove. Shows the toes, the root, actual throat, the face, the theoretical throat, legs, leg side weld, fusion zone, penetration, original surface work. Seam. In the process of the metal pieces between the roller type of the electrodes revolve with the current automatically turned on and off with the speed at which parts are set to move. The CBs do not normally use the seam welding because of the type of the welding is most often industrial manufacturing. Alright, parts of the weld for you, the procedure would be meet with the job requirements for the important. You become familiar with the terms you described in figure 320. Shows that with the groove belt fillet weld, the face is exposed. Surface of the weld on side of the weld with the made with the toe in junction between the face of the weld, the base metal with the root of the weld, included with the joints back of the weld, the intersect with the base metal surfaces. We will then look at the triangular cross section of the fillet weld shown view B. The leg is proportional to the welds of the toe of the root. The root is the distance of the root to the point of the face of the weld along with the line perpendicular to the face of the weld. Theoretically, the face forms a straight line between the toes. Note that the terminal leg and the throat apply only to the fillet weld. The termination side of the groove weld, figure 320. View A, such factor for the depth of the groove of the root opening of the groove of the angle must be taken into consideration. Size of the fillet weld. View B refers to the. Alright, so we have the size of the convex fillet, the size of the concave fillet, and the weld reinforcement, butt weld reinforcement with a welding micrometer. 322 show the zone of the weld, lengths of the weld, and weld with the two legs are assumed to be equal size and length of the weld specified. A gauge weld determining the size of the weld is known as the welding micrometer. Figure 321 show the welding micrometer used to determine the various dimensions of the weld. Some of the other terms should be familiar with. They used to describe area zone weld discussed earlier with the term fusion of the melting together with a base or filler metal. Fusion zone shown figure 322. Is the region of the base metal of the actual melt of the depth of those fusions. The distance of the fusion extends into the base metal as well as previous welding pass. Another zone of interest of the welder, the heating affected zone, figure photo 322. The zone is included with a portion of the base metal that has not been melted without the structural mechanical properties of the base metal have been altered with the welding heat. Because mechanical properties of the base metal are affected with the welding heat, it is important that you learn techniques to control the heat input. One technique often used to minimize heat input is the intermittent weld. This was discussed in this and other techniques as we progress through the chapter. First, we will discuss some of the consideration of the effect of the welding joint design. Welding joint design detail of the joints include both the geometry required dimensions called for the joint design with adjust what the type of the joint design is best suited for the particular job that depends on many factors. Although weld joints are designed primarily to meet strength and safety requirements, there are other factors that must be considered. A few of these factors are as follows: your square butt joint, single V butt joint, double V butt joint, and it shows figure 323, show the butt joint. Where the load of the tension compression, whether the bending of fatigue or the impact of the stress will be applied, how the load will be applied, whether the load will be steady, sudden with a variable direction, load applied with the joint, with the considered with the preparing a joint. The consideration must be made with the ratio strong of the joint compared with the strength of the base metal with the ratio of the joint efficiency. Efficiency joint with the one that is just as strong as the base metal with the normally joint design is determined the designer, engineer included with the project plan with the specification, even with the understanding of the joint design with the weld enables you to produce better welds. Earlier in the chapter, we will discuss 5 basic types of welding joints: butt, corner, T, lap, and edge. While on many of the variation, every joint over the weld will be one of the basic types. Now we will consider some of the variation welded joint design efficiency over the joints. Butt joints, square butt joints are usually primary over the metals of 3/16 of an inch or less in thickness. Joint is reasonably strong with the butt is recommended with the metals are subject to fatigue with the impact loads. Preparation of the joint is simple since the month only requires matching edges are placed together. However, there was any other joint with the important with the fitted together correctly with the entire length of the joint. It's also important that you all know allow enough root opening with the joint. Figure 323 show the example of the side of the joint with a welding metal greater than 3/16 of an inch in thickness is often necessary to use the grooved butt joint. With the purpose of the grooving is to give the joint with the required strength. When you use the groove joint, it's important that the groove angle is sufficient to allow the electrode into the joint there. Otherwise, the weld will lack penetration and may crack. However, there also should be avoid excessive beveling because of the waste of both weld metal and time, depending on the thickness of the base metal of the joint, is either single groove the groove on one side of it only, or double groove on both sides of it. As a welder, you may probably use a single V or a double V groove joints. A single V bubble joint, a VB, uses plates 1/4 inch to 3/4 inch in thickness. Each member should be beveled, included the angle of the joint is approximately 60 degrees angle from the plate, or 70 degrees, 5 degrees for a pipe. Preparation of the joint requires a special beveling machine or cutting torch, which makes it costly for the square butt joint, more costly than the square butt joint. It also requires a more filler metal material than the square butt joint. However, the joints are stronger than the square butt joint above there. Such square joint is not recommended when the subject of the bending of the root weld. Double V butt joint is an excellent joint with all conditions. The primary use of the metal is thicker than 3/4 inch, so that it can be used on thinner plate with where strength is critical. Compared to single V joint, the preparation time is greater, but you can use less filler metal because of those areas concluded angle because of the heat produced by the welding. You should alternate weld the deposit of the welding first on one side and then on the other side of the practice produce a more symmetrical weld to minimize warpage. Remember to produce good quality welds using the groove joint. You should ensure the fit up the consistency of the entire length of the joint and the use of the current groove. Or shows a single bevel, double bevel, single J, double J, single U, W. Angles use the correct root opening. These are the correct root faces of follow these principles are better produced every time. And the others stand with groove butt joints design include the bevel groove, the J groove, the U groove. Shown 340, figure 324 additional type of the groove welds. Alright, corner joints. The flush corner joint in figure view A is designed primarily with welding sheet metal of 12 gauge thick or thinner. Roots to the light material to cover the deep of the penetration. Sometimes the difficult design can support only moderate loads. Half open view B is for use of welding materials heavier than 12 gauge penetration. Is better than flush corner joint, but is used only when making with the moderate loads. And full open view C produces a strong joint, especially when welded both sides. Useful the welding plates for all thicknesses. T joints. A square T joint, it also requires a fillet weld that can be made from both sides. It can be used in light and fairly thick materials, maximum strength, considerable welded metal. should be placed on each side of the vertical plate. Square T-joint, single bevel T-joint. Alright, C, double bevel T-joint. A shows a single fillet lap joint. B shows a double fillet lap joint. Alright, 326 shows a T joint with a fillet welds. You have an edge joint, flange edge joint, A, B, and C. Or a single bevel T-joint with a view B within B with with a more severe loading with a square T-joint because of the better distribution of stress, generally with a U of the plate. 1/4 inch less thickness wherever the welding can only be done from one side. Double bevel T-joint. View C is for where the heavy loads applied with the welding can be done on both sides of the vertical plate. Lap joint, single fillet lap joint, view 27, view A, easy with the weld, since the filler metal is simply deposited along the seam. The strength of the weld depends on the size of the fillet. Metals up to 1/2 inch for the thickness, not on subject to heavy loads, can be welded within this joint. When a joint is to be subject to heavy loads, you should use the double fillet lap joint, view with the welds properly. The strength of the joint is very close in strength with the base metal. Edge joint with plain edge joint is suitable for about 1/4 inch for less thickness and can only sustain light loads. Each preparation of the joint may be done in shown view B's and C. Alright, this shows your axis of the welds, flat position, horizontal position, that's first fillet, one fillet for F, 1G for flat groove, 2F for T-joint, and 2 T-joint, fillet T-joint, 2G, 3F, vertical position 3G, overhead 4F, 4G. Our welding properties. Welding is done with a 4 position flat, 1 horizontal, 2, 3 vertical, 4 overhead fillet. Groove welds can be made in all positions, shown with the various portions of the plate. The American welding size identified with the position, number, letter, designation for the instance. 1G refers to a groove weld that is made in a flat position. Here, 1 is used to indicate flat position. G indicate with the groove of the fillet weld with the metal of the flat position. Number 11 with the designates of the 1. F for fillet. Number letting designates that refer to the test position. Position welder should require during the welding classification. Qualifications as steelworker, therefore, is a good possibility someday you will require to certify perform a welding qualification test. Therefore, it's important you have a good understanding, comply with the techniques of the welding in each test position. Alright, it shows the welding position for a pipe. You have groove 1 horizontal roll position, 2 vertical position, 3 5G horizontal fixed position, and 6G incline position. Because of the gravity position which you with the welding effect with the flow of the molten filler metal, you with the flat position also possible because of the gravity draw of the molten metal downward in joint, making the welding faster and easier. Horizontal welding is a little more difficult because of the molten metal that tends to try to slag follow the downhill onto the lower plate. Vertical welding is done with a vertical line, used from the bottom of the top. Over the thinner material, the downhill, the downhand welding may be easier. Overhead position, most difficult position because of the welded metal flow downward in the position required with considerable practice on your part. Produce good quality welds. Although the term flat, horizontal, vertical, overhead sufficiently describe the position for the plate welding, they are not adequately describe pipe welding. In pipe welding, there are 4 basic positions used in Figure 330. Note that the position refers to the position of the pipe. Note the position of the welding. Test 1G is made with the pipe at its horizontal position. In this position, the pipe is rolled so that the welding is done with the flat position and with the pipe rotating under the arc. This position most advantageous of all pipe welding positions, while the welding in 2G of the pipe is placed on the vertical position so the welding is done. Horizontal position 5G is a position similar to 1G position. Axis of the pipe is horizontal, but you're using you're using when you're welding a 2G position, the pipe is played with the vertical position welding. It can be done in a horizontal position. 5G is similar to 1G. The pipe is horizontal, but when you're using 5G position, the pipe does not turn or roll during the welding operation. Therefore, the welding is more difficult in the position. When using 6G position pipe welding, the axis of the pipe at a 45-degree angle with the horizontal pipe does not roll. Since the pipe is not rolled, welding has to be done in all positions: flat, vertical, horizontal, overhead. If you weld the pipe in a position, you can handle all other welding positions. Note that no 3G or 4G test pipes are welding, since most pipes are groove welds and identified on letter G. We'll discuss about the techniques used in welding various positions later in the training manual, but no later talks about the effect of the heat on the metal. Expansion, contraction. When a piece of the metal is heated with the metal expanding upon the cooling, and the metal contracts and tries to reassume the original state. The effects of expansion. Contraction shown in Figure 331, View A, show with the bar that it restricted anywhere with the bar is heated with the free expands in all directions. The bars will allow it to cool without strain with the constraints in the original dimension. When the bar is clamped to view B with a heated with expansion limited unrestricted source of the bar cools to the end still contracts uniformly in all directions. As a result, the bar is known as deformed. It has become narrower and thicker as shown in view C. Their same expansion with contraction forces act on a welded metal base metal with a welded joint. However, when two pieces of the metal are welded together, the expansion contraction may be uniformly throughout all parts of the metal. This is due to the difference of the temperature of the actual welding joint and to the edge of the joint, the difference of the temperature it leads. So you have a flat piece of work pulled out of line, vertical work pulled off center, flat work drawn to a curve, and those D spacing closing sources can be caused by welding. Internal distortion warpage shown in Figure 322 show the most common difficulty with the likely to encounter. When you're welding a single V butt joint with the highest temperature surface of molten fuel, the temperature decreases if the move toward the root of the weld away from the weld. Because of the high temperature of the molten weld is where the expansion contraction greatest for the weld begins to cool the surface of the weld. The joint contracts, shrink the most, causing warpage distortion. View B shows how the same principle apply to the T-joint. View C and D show the distortion cover the welding bed in one side over the plate and welding two plates together without proper tack metal. All metals will expose the heat during the welding and expand with the direction of the lead. Resistant conversely with the metal cool with the contract with the same amount. Therefore, if you want to prevent and reduce distortion weldment, you have to use some of the methods to overcome the effects of heating and cooling. Controlling distortion, you can control the distortion caused by expansion contraction during the welding following the simple procedure listed below. Alright, this shows a chain intermittent fillet weld, and this shows a staggered intermittent fillet weld. Shows a intermittent bell weld direction of weld 1, 2, 3, 4, 5, 6, and 7. Backstep weld 1, 2, 3, 4, 4, 3, 2, 1, 1. Alright, proper edge preparation fit up. With the discussed earlier in the chapter, proper edge preparation fit up is essentially good quality with the welds, but make a certain edge of the properly beveled spacing adequate. You restrict the effect of the distortion. Additionally, you should use the tack welds, especially on long joints. Tack welds should be spaced at least 12 inches apart, running approximately twice as long as the thickness of the weld. Control your heat input. You should understand that the faster the weld is made, the lesser heat will absorb with the base metal. After the gain in welding experience, become easier for you to weld the seam with the minimum amount of heat by the simply speeding up the welding process. Regardless of the experience, often necessary for the welding technique designed to control the heat. Intermittent weld, sometimes called the skip weld, use it instead of the one continuous weld. When using intermittent weld, the short weld is made with the beginning of the joint. Next, you skip to the center of the seam, weld a few inches, then you weld on the other end of the joint. Finally, return to the end of the first weld. Repeat the cycle until the weld is finished. Shows the intermittent weld. Another technique with the control of the heat input with the back step of the method of using the technique deposit short weld beads from right to left along the seam. Preheat metal discussed earlier. Expansion contraction rates, uniform structure during welding due different temperatures throughout the metal. It shows the incorrect way to pack space amount and welded passes, allowing distortion. To control the force expansion contraction, preheat with the entire structure before welding. After the welding is complete, you allow the structure to cool. More by the preheating and post-heating discussed later in the training manual. Limited number of the weld passes. Keep the distortion minimum using a few weld passes as possible. You should limit the number of the weld passes to a number necessary to meet requirements of the job. Using jigs and fixtures, some hold the metal in a fixed position prevents extension of the joints. Using fixing jigs and fixtures can help prevent distortion. Jigging the fixture is a simple device. Use hold metal rigidly into position during the welding operation. Allow the distortion. Simple rate of distortion caused by the expansion contraction is allowed during the fit up. They reduce the distortion or angle of the parts of the weld slightly opposite direction in which the contraction takes place. When the metal cools, contraction forces pull the pieces back into position. Shows how the distortion can be overcome in both the butt and T joint. The more to be a good beginner, good welder than just being laying a good bead. There are many factors that must be considered later. We discuss additional techniques you can apply to specific welding situations. Or the welding procedure. There are many factors involved with the preparation of welding. Join with the detailed method of practice with welding. Particular weldment called the welding procedure. The welding procedure is identified with the welding process pertaining with a particular job. Generally, the various rules include the welding profit, the type of the base metal, the joint design, welding position, type of the shoe, the preheating and post-heating requirements, the welding machine setting, and the testing requirements. Welding procedure for the produce the weld meet requirements commonly used by the American Welding Society. Procedure for the structural welding code used by the design, construction, steel structure. Another code with the used by the construction, steam boiler, and pressure vessels used by the American Society of Mechanical Engineers. The codes provide a standardized guide of proven welding practice and procedures. While you are not directly responsible for developing the welding procedure, you could be assigned to welding job required for the following them. For example, the job assigned with the Navy construction force unit, the company with the set of the drawing specification welding required for the job specification normally required to accomplish according to specific code requirement for the instance. If the unit has to fabricate weld steel with the structure specification, it may require the welding accomplished according to AWSD 11 structural welding code. The units that are responsible for ensuring the welders assigned with the job are qualified with the produced welds according to the welding procedure specification as shown in Figure 337 of the welding procedure specification. Similarly documented with provides detailed requirements variable to specific welding application. The MMCB welding procedure specification normally prepared with a certified welding inspector with the local Navy Construction Training Center with the structural welding code, along with the project drawing specification welder inspector to develop the welding procedure specification that meets the requirements of the job. The importance of the document is that it ensures that each of the variables can be repeated qualified welders. Once the welding procedure specification have been developed and qualified, the welders are required to perform welding procedure qualification tests. After the test is complete with the welded specimen are tested according to requirements of welding procedure specification, may use the destructive or the non-destructive test. Example, the destructive test of the guide bend test, the X-ray test, considerable the non-destructive test discussed with greater detail later in the training manual. Note, when you're assigned with the welding job, make a thorough examination drawing specification and look carefully at the notes of the drawing. Section 5, metals with the specification specific codes are cited and from the project supervisor that you are receiving the training needed to perform the required welds. Okay, drawings and sketches are used to convey the idea of the engineer. The skill of the craftsman is working within the shop. The welder must be able to work from a drawing in order to fabricate metal parts exactly where the engineer has designed them. Reading drawing. To read a drawing, you must know that the engineer used the line dimension knows to communicate with the idea of the paper in the section. Briefly discover that these drawing elements of the material more for the discussion refer to the publication, blueprint, reading, sketching, and Navedtra 177 F1 Engineering A3 Navedtra 1069-6. Alright, lines show many of the different type of lines for the drawing. You can see each of the specific meaning of the understanding and interpret the drawing correctly. Discover the few of the most important type of the visible line, sometimes called the object line. You just show the edge of the object for the visible view of the viewer. For example, look at the out of the wall of the room. You can see with the outline with the wall, depending on the walls you're looking at. Outline drawers, windows on the drawing, the visible outline, the edge of the can be shown with the visible line. The drawing is described in Figure 338. Now looking at the wall again, assuming that the wall is wood framing now, there are studs and the framing members inside of the wall that cannot be seen. Also, the wall may be to contain other items such as water pipe and electrical continuity that also cannot be seen on the drawing edge of the concealed stuff. The other items should be shown as hidden lines. These lines commonly give the drawing, and we can imagine the hidden lines are the more difficult to decipher without another ways the stuff. The other items can be seen. Imagine the cutaway of the wall board coverage of the wall. Replace it with a sheet of clear plastic. Clear plastic be thought with the cutting of the view plane through the previous concealed stud and pipe and continuity is now visible. Note the items in the drawing in this visible line rather than hidden lines of the view type that's called the sectional view of the drawing. And view is called the section drawing. The section drawing commonly used to show internal components of the complicated object. Many types of see with a line drawing the visible surface of the section line. When these lines or the section lines are used to show the different type of materials. And it shows a sample letter of the welding procedure specification, which you can get off the Department of Defense forms. And then this is another sample. And then here comes a this shows your visible lines, hidden lines, center lines, draw mention lines, extension lines, leaders, phantom datum, stitch line, break, out cutting, view plane, cutting plane context. Okay, so let's continue to read the rest of the page. Some of the type of the section lines are likely to encounter with the welder, shown figure 339, another U with the line form with symbols such as the welding symbol to discuss later in this chapter. So 339 shows the section line various over the shield with the copper, brass, bronze, composition, cast iron, malleable, general U with the material of aluminum and its alloys, zinc, lead, and white and metal, babbitt and alloys. Dimension, while engineers just align to describe the shape of the form of the object with the dimension provided with a complete site with a description dimension you with the draw. There are two types of size and location applied with each time with the size of the dimension shown. Size of the object, part of the object, location of the dimension you with the describe the location feature example, both sides of the location dimension shown figure 340. Shows location lines, location shape lines, welding symbol the form of the lines of the size dimension of the note with the diameter holes and the reference in the dimensions, extension lines and dimension lines and the hidden lines. While on the subject of the dimension, it should be dealing with the larger objects delve within the drawing with the true with the side of the initiative of the engineer, the draftman reduce the size of the object with the scale. For example, while drawing the 40-foot tower, dwelling may be prepared using a scale of 1/2 inch to 1 foot. In this case, the height of the tower on the paper is 22 inches. The scale that you would prepare the work drawing, also note with the drawing may be the fractional side of the discuss here with the graphic scale with the such as shown figure 340 Navy. Both numerical graphical scales are usually shown in the construction drawings. While using the drawing of the dimension of the object should never be measured with the scale directly for the drawing of the measurement. Frequently inaccurate with be changed the atmospheric condition with the cases of the drawing paper to shrink and extend and expands to ensure the accuracy. Always use the side of the location dimension shown on the drawing. That if a needed dimension is not shown on the drawing, you should check with the graphic scale. With the cells always shrink and expand at the same rate of the drawing paper. Note drawing notes. You for the different purposes, either general specific nature, or one example to have the nose for the two nose figure 340 to give it the inside of the diameters of the whole everything. You can see with the notes of the sky as mentioned with the specific notes in that by using later lines each for the note referred to the specific hole instead of hole of the general note is provided with additional information does not apply with one particular area of the feature of the drawing. For example, the drawing shown figure 340 containing the general note saying all holes should be using the tolerance of plus or minus 1/64 of an inch. Drawing views. Look at the drawing shown the 341 and type of the drawing. With the pictorials drawn with the drawings, figure use to show how the object will appear with the manufacturing project drawings, or view the working drawing simple A. Items such as the metal washer for much complex items shown in figure 3-4. The producer is difficulty to provide with a complete description of a particular drawing. In this case, it's common practice to prepare orthographic drawing to describe the object fully. Show the 341 show the pictorial drawing and steel part. Now you see the top and front views and the orthographical. Assuming you hold the object shown in figure 341, with your hands you'll hold the object so you're looking directly over the top face of the view. With the top view of the drawing of the view is called the orthographic drawing. Obviously, the orthographic drill only with the top view of it is insufficient enough to describe the entire object. Therefore, additional orthographic drawings of the worm over the other faces of the object is necessary for the number of the orthographic view that needs to describe the object fully depends on the complexity of the object. For example, the simple manila wash can be fully described using only one orthographic view. However, the extremely complex object may require as many as 6 views of the top, left, right, side, back, and front, and bottom. Many objects see with the steel part shown in figure 341 is insufficient, describing either the 3 views, the top, front, and right side. The object shown in the orthographic note of the top, front, and right sides of views are shown in the 342. Note the placement view of the figure 342 with the chain practice should be either aware with the reading and the orthographic divide with the chain practice with the top view. They also place above the front view, right side view in place. Right over the front view, the additional views are needed with the left side, but they also drawn with the left over the front view with the bottom of the drawn from the bottom from below with the right front view. Placement of the back view somewhat flexible, however, they usually drawn left side with the left side view with the reading and understanding the difference of the orthographic view should sometimes follow helpful. Prepare a pictorial sketch. You can find with the discussion sketching blueprint reading the Navy trial of the 177, the 50 F1. Think of the drawings, form of the communication intent with the understanding of the necessary information needed to fabricate to an oral object regardless of the complexity and its importance for the learning and reading drawings. Or handling care of the drawing, special care for the extra handling of the drawings are not being used to keep them on with the rack with another assigned plane of the storage the drawings are available. There may be difficult to impose with the replace with loss of damage. Note that we discuss special symbols. These symbols the welder must be able to read and understand how they are used to convey information. Welding symbols. Special symbols used with the drawing to specify the welder welds are located at the top of the joint. Used with the weld says side of the mount with the weld metal with the deposit of the joint with the symbols show that the American Welding Society will come in contact with these symbols at any type of the welding job with the set of the blueprints. You need to have the working knowledge of the basic welding symbol, the standard location of the elements of the welding symbol. Standard welding symbol consists of the reference line and the arrow. The tail of the reference line become the foundation of the welding symbol. If it's applied with the welding symbol, the dimension of the data to the weld arrow symbol to connect with the reference for the end joint area to be welded the direction of the arrow. No bearing of the significance of the reference line with the tail of the welding symbol is used only when necessary include specification process for the other reference information. Welding symbol with a symbol from the specific type of the weld we discussed earlier. Fillet groove with a surface plug and slot. All types of weld. The basic weld symbol is shown figure 344 of the weld. Shift of the bead, fillet, and plug square, square, V, bevel, U, J, and flare V and flare bevel. Shows a fillet and J groove, bevel, flare, bevel, groove, corner flange, in your welding symbol the 345 of the reference line. Shows the fillet weld on the arrow side. Shows a fillet weld on the other side, and shows the fillet weld on both sides. Okay, and then figure 347 shows the arrowhead indicates the bevel plate. Symbol is only proof of the information required with the welding. Symbol determine the welding. Symbol to refer to the total symbol that would include the information needed to specify the weld required. Figure 345 shows the weld symbol to apply with the reference line over the vertical level of the weld, shown with the drawn left of the slanted leg with regardless of whether the symbol is of the fillet, bevel, J grab with the flare, bevel, weld with the vertical leg is always drawn to the left. Show the significant position of the weld and symbol with the position of the reference line with the U with the weld symbol is lower side of the reference line with the term the arrow side with the UB shown with the weld, the symbol the upper side with the reference for the term the other side with the weld, the symbol the place for the lower side with the reference line with the weld, symbol of the with the both side with the VUC. Well, only one edge of the joint is beveled, but it is necessary for the show of the member to bevel the joint, and such beveled joint is specified with the arrow welding. Symbol joints posed with the evident break and tore of the member of the beveled shown figure 347. Figure 348 show the elements that may be added with the welding symbol, the information applied with the reference line with the welding symbol, the read to the left or the right, regardless of the direction. Arrow. Dimension, note for the designated location, side of the length of the pitch, center spacing, the groove angle, and the root opening over the weld location determined the side with the reference of the wedge weld shown in place in figure 49 with the dimension applied to the symbols. Okay, so we have the finished contour symbol, the root opening filling plug with the size of the inches, reference line with the specification, process for the other reference, the maybe a tail may be omitted with the reference used in line. The basic weld symbol, the detailed reference. Then you have the groove angle included with the quarter sink plugs and length of the weld in inches. The pitch for the spacing, center spacing with the inches. The filled weld symbol, the weld all around. Arrow connecting the reference line to the arrow side of the joint. These all points groove membered and beveled J grinds. Alright, so the quarter inch fillet weld, length is 3 inch fillet weld, length a length of 2 inch 5 inch center pin length pitch fillet weld, a half inch by 3/4 inch groove weld, other side arrow side, no, yeah, other side arrow side, other side 1/8 inch root open bevel groove, groove angle 60, other side. Alright, shows the symbol, fillet 3/8 inch, with a meeting of 3/8 inch toes, 2.5 inch 2x5 spacing, so we have 2 inch weld spaced 5x5 apart. And then 3C show the double bevel groove, half inch weld and half inch groove angle 45 inch. Yeah. Okay, flush, convex, and concave are your contours. You have a weld on and fillet weld area. Figure 350 show the meaning of the various weld with the dimension. Symbol notice the size of the weld is shown on the left side of the weld. It's symbol to figure 350 length of the pitch of the weld. The area will indicate the right side of the weld is shown view B. For the T-joint, 2 inches intermittent fill weld shown 5 inches apart with the side of the groove of the weld shown view C. Both sides of the 1/2 inches and over the 60-degree groove on the other side and the 45-degree on the arrow side. Supplementary symbols. In addition to the basic weld, the supplementary symbols may be the edge of the welding symbol. Some of the most common supplementary symbols are shown in Figure 351. Contour symbol, even the welded symbol show how the face of the weld is formed. The addition of the contour symbol, the finish symbol, even to indicate the method of the forming contour of the weld. When the finish symbol is sheathed, it shows the method of the finish and the degree of the finish. For example, the sheath of the U to indicate the finishing, the chipping, the M means for the machining, and the G means for grinding. Shows how the contour finishing symbols are applied with the welding symbol. The figure shows the weld is grounded with the flush or with the note. The symbols are placed on the same side with the reference line is with the weld symbol. So you have the groove, you have your shield metal arc welding and the back gouging. Same reference line, multiple reference lines. So another supplementary shown in Figure 351 is the welder all around symbol. The symbol to play for the welding symbol to continue all of the round joints. Weld cannot be made in shop identified with the fillet weld symbol shown in Figure 351. Symbol is black flag pointing to the welded symbol, specifying additional information. Some of the necessary for the certain welding process with the type of the electrode, some type of the other preferred necessary to complete the welding. Cave of the note is placed on the tail of the reference line. Additional information needed from the tail. Multiple weld symbols when you fabricate the metal part. There are many times one type of the weld is needed on the same joint. For example, the joint may be both a bevel, groove weld, and a fillet weld. This term method of illustration, even the welds, is shown on the note, but each welding shown with a bevel groove weld is completed first, and then followed by the fillet weld. So we have to do the first is the closest to the arrow, and then the farther away is the second arrow, same reference line. Additional welding symbols, Figure 355 shows examples of how welding symbols may appear on the drawing. Figure shows you have eyeglasses A, B, and C, and protection helmets. Steel piping column to be welded to the base plate with a weld test. Tells welded the pipe. That the pipe beveled at 30-degree angle, followed with a bevel, the groove weld with the roll around, followed by 1/2 inch fillet. That the weld all around the joint, finally finished with the fillet weld by the grinding flush contour. And the fillet weld symbol that indicates all of the welds to be accomplished by the field with additional information. Weld the symbol of the welding non-destructive test ANSI AWS A2486. Safety. Perhaps frequently occurred welding operation, many instances of the result of serious injury to the weld of the person working in immediate most cases, and perhaps mishaps occur because of the careless language down with the misuse of the available equipment. The precaution of the available applied to specific available equipment. The precaution applied with specific welding equipment pointed out in the chapter to cover the equipment of the section, particularly interested in subject of the topics for the protective clothing, eye protection of the devices, practices applicable to personal safety, the operator, personal working nearby. Prior air protection, eye protection is almost important. Is the utmost important to cover the welding operator, other personnel, so the help interpreter and inspectors who are in vicinity of the welding cutting operation. Eye protection is necessary because of the hazard posed with the stray flashes, reflected glare, high flying sparks, or probes of the molten metal. Advice you the eye protection include the helmets with the goggles. In addition to providing eye protection, the helmet is provided the shield against the flying metal with the ultraviolet rays for the entire face of the neck. Show several types of eye protection devices in common use. Flash goggles view A are worn in term of the welder. Helmet, a person working around the area with wear of the welding operation taking place with a spectacle type. The goggles have the side shield that may have either of the adjustable and non-adjustable noise bridge. I couple the cover type of the goggle with the view B with the R4 and fuel gas well with the cutting operation of the air counter filled with the configuration of the face. The goggles must be fitted with the shape of the filter lens then is suitable for the type of the work being done. Note with the eye cup and cover type of the goggles are known to be the substitute for any arc welding helmet. For electric arc welding, arc cutting operation helmet having suitable filter lens is necessary with the helmet shown in figure VC as an open called open window flip-flop filter lens 2 inches by 1.25 inch with the side of the helmet shown figure D with a 4.5 inch by 5.25 inch window with a larger window affords the welder wider view with especially with the welder working on a confined space with heading and body movement that is restricted. When welding is the location other than the welders working on the welder showing the welder where flash goggles beneath the helmet to provide protection with a flash cover the other welders. Flash goggles will also serve the eye protection where chipping the slag to prevent the weld deposit. Helmets and welding goggles, UV eye protection made available to non-flammable insulating material with the fitted with a removable protective colored filter with a clear covering lens. Note for the purpose of the clear covered lens with the protective filter lens against the pitting of the cover with the spark with a hot metal splitter with the clear lens must be placed on the outside filter lens with the clear lens must be replaced and pair vision. Filter lens finished with a variety of shades with the designated with the number, the lower number, the lighter the shade, the higher the number, the darker the shade. Show the recommended filter shade varies where welding operation filter lens with the shade, the number is selected depending on the type of the work, somewhat with the preference for the use of them. Remember that filter lens serve the two purposes. Of the first, serve the diminish the intensity of the visible light with the paint. Wherever there is no glare, the welding area can be clearly seen. The second, eliminate harmful and the infrared ultraviolet radiation coming from the arc of the flame with a consequently filter lens shape and with aim. Number shall select must not vary with more than two shade with the number recommended in table 3.1. Rule of thumb, when selecting a proper shade of the filter lens, the electrical arc welding helmet is placed with the lens, and the helmet will look through that lens as if you were looking welding. Look at the exposed bar light bulb with the shade of the you can distinguish its outline. If you can, then you use the darker shade lens. Repeat the test again and again when you no longer see the outline of the bulb. Then the lens is proper shade. Remember, the test should be performed in the same lighting conditions of the welding operation to be performed. Welding in the shop of the may require the shade lighter lens within the same job as being performed on a bright daylight. For field operation, the test must be performed looking at bright reflecting object. Warning. Never look at the welding arc without proper eye protection. Looking at the arc with the naked eye could lead to permanent eye damage. If you receive flash burns, then you should be treated medical personnel. Variety of special welder clothing is used to protect the parts of the body that include the selected areas. We show the welding gloves and mitts, A and B, leather apron, leg apron, cape and bib, the sleeves and coat and gloves. So, with size and location, nature of the work with the performed during any of the welding cutting operations, you always wear a flame-filled gauntlets, gas welding or cutting 5-finger gloves like shown in view A and B. Electrical arc welding with the 2-finger gloves or mitts, shown in view B. Both types of gloves protect the hands and the heat with a metal splatter. 2-finger gloves have an advantage over the 5-finger gloves in that they reduce the danger of the weld splatter. Sparks lodging between the fingers can also produce the finger shafting sometimes occurs with the 5-finger gloves with the electric arc welding. Many light gas welding brazing jobs now require special protective clothing other than gloves and goggles. Even there's essential the way the wear clothes protect properly with the spark very like lodge rolled up and sleeve with the pockets of clothing, cuffs of the trousers. Overall, the sleeve should be rolled down. The cuff button. The shirt's collars also should be fully with the button. Trousers should not be cuffed on the outside with the pockets with the protective of the bottom down. Flaps should be eliminated with the front. Overall, the apron of the cover clothing must be free of the oil and grease part with a high top shoes, safety shoes, low cut shoes that are hats should be covered with a spark with a molten metal kind lodged in them, especially when you're sitting down. Medium and heavy gas welding, electrical welding, and vertical overhead welding position requires special flame-proof clothing made of leather. Other suitable material clothing is designed to protect you against radiation, heat, splashes of hot metal, and sparks. Clothing consists of the apron sleeve with the combination sleeve of the bib jackets overall with the afford the chance of the choice of protection depending on the specific nature of the particular welding or cut, and the sleeve provides satisfactory protection of the welding operation at the floor or the bench level. The cape and sleeve of the particular shoe suited for the overhead welding we cover the protect the back of the neck with the top of the shoulder, the upper part over the back. And the chest, the U of the bib of the combination from the cape of the sleeve of the give of the added protection and chest of the abdomen of the jacket shall be worn. There is the knee of the complete all-round protection upper part of the body, especially true with the severe welders are working in close proximity and one another. The aprons overall provide protection with legs and suited with the operation with the floor. Figure 358 show the some of the protective clothing available to welders. Prevent head burns during overhead welding operation. You should wear leather and flame-proof caps under the helmet. The air plugs should be worn with the keep the spark of the splatter for the entering and burning in the ears. Whether welder is exposed with the falling sharp of the object with combination welding helmet and hard hat should be used for you heavy work with the fire restraint leg guns. High boots should be worn. Shoes and boots having exposed with the nail heads. Rivets should not be worn. Oil skins or plastic coating must not be worn in any welding operation. Note if leather protective clothing is not available, or the woolen clothing is preferable to cotton. Woolen clothing is not as flammable as cotton. It helps protect the operator from change in temperature caused with welding. Cotton clothing, if used, should be chemically treated to reduce its flammability. Alright, Chapter 4, Gas Cutting.